All right, geometry guys, this is the final part of Unit 5. This also happens to be, could be, should be the final thing for Geometry A, the final new thing anyway. So we're talking about parallel lines and proportional parts and what happens when you start drawing lines to triangles. So start with this, triangle proportionality theorem. If I got a triangle, I draw a line through the triangle. So I've got triangle ABC. I draw a line through the triangle. The triangle is parallel to one side. All right, that's the important part. The triangle is parallel to one side. When I do that, here's what happens. All right, so I drew XY, it's parallel to AC. Here's what happens. Those two lines, these two sides that are created, this one, this one, this one, this one, they're proportional to each other. So AX over BX is equal to CY over BY. All right, so part over part equals part over part. All right, splits those sides into segments of proportional lengths. That means those two sides are in proportion. They're going to be the same thing. So if I take a look, PT is 7.5, SR is 3. Sorry, TQ is 3, SR is 2.5. Find that guy. Find PS. Well, I know these two are parallel. That means my sides are in proportion. So if I say it this way, 7.5 over 3, it's got to be equal to Y over 2.5. That I can solve because this is equal. I go multiplying diagonally. So here, 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 here. So 3Y equals 7.5 times 2.5. When I do that, I end up getting 18.75. Well, division, Y is going to equal 6.25. So that's how big this segment is. And it should make sense. All right, if I compare these two, 2.5 is a little bit smaller than 3. It should make sense that this answer is smaller than 7.5. All right, that's kind of an ongoing, you should kind of keep that in your head. Does my answer make sense? So flip that around, saying this. Now, once again, I have a triangle. This time I happen to draw a line through it. And in doing so, I happen to put these in proportion. Then if I do that, then I can say they're parallel. All right, so it's just kind of the same thing, just flipped around. So we'll call this RT or something, I don't know. So XR over YR side by side is equal to ZT over YT. So if that's the case, then yeah, RT is going to be parallel to XZ. If I do that, that's going to be in proportion. So EH is 3, HF is 9, DG is 1/3 the length of the GF. So another way, the simple way to think about it is that it's 1/3. So let this be 1, let this be 3. So I've got to test, do those two make sense? So does 1 over 3 equal to 3 over 9? Well, those two are exactly going to be correct. That's going to be fine. So yeah, I can say those two are parallel. Absolutely. So the midsegment of triangle is a segment with endpoints that are the midpoints of two sides of the triangle. Haha, midpoints. Reminder, midpoint means exactly halfway. All right, so we've got a midsegment here, we'll call that M. Got a midsegment here, we'll call that, I don't know, N. Midsegment here, we call that T. Now, a midsegment basically is just connecting these two. This black one is a midsegment of this whole bottom side. This red one, MT, is a midsegment of this whole side. This midsegment here is a midsegment of that whole side. So those are your three midsegments, and they are parallel to those opposite sides. And here's kind of what's handy about that, is if I've got a triangle midsegment, it is exactly half of the length of the side it's parallel to. So it's parallel to this side, and it's also half of that side. So like if this is 10, this is 5. If this is 20, this is 10. This is a number, this is half of that number. That's the way you want to remember that. So if I've got this kind of situation, mid-segment, mid-segment. So if I'm looking for a mid-segment, this whole side is 13. I want half of that for xz. So real simple, 13 divided by 2 is 6.5. Thank you for playing. ST is this side right here. Is 7. So all I got to do is take 7 times 2. That's going to be 14. Number one mistake kids make is that they somehow magically think that they're going to be equal to each other. They look at this and they see 7, but then they think this whole thing is 7. At some point, logic has got to take over and say there's absolutely no positive way that's right. So you got to kind of think about this a little bit. So now the final piece, RYX, this angle right here. You want that. Why is it 124? Well, let's take a look and see if we can figure it out. Here's why. Mid-segments are parallel, right? Yes. So if these two are parallel, let this be a transversal. Okay, so let's extend this and kind of look at this. This is 124. This is also 124 because these two are alternate interior angles. Yeah, something from way back in the first unit that we ever talked about is coming back to haunt you guys. All right, so let's take a look. IJ is a midsegment of FGH, so that means IJ is going to be parallel to that. It's also going to be measured to half of that. Find X, find Y. Here's what's kind of handy. Midsegment's cut in half. So that means to figure out X, 2X plus 5 is going to be equal to 5X minus 7. So a little algebra skills coming in. So 3X equals 12. So X better equal 4. So then this piece is this. 5y plus 1 does not equal 8y plus 6. Those two aren't equal, but double that is, remember, this is going to be equal to half of this. So to fix that, I have to multiply it by 2. So it's 10y plus 2 equals 8y plus 6. Subtract 8y, subtract 8y, subtract 2, subtract 2. So 2y equals 4. So y is going to equal 2. So last piece. F is 50. H is 30. Well, if H is 30, remember, these two are parallel. So that makes this 30. Why? Because they're corresponding angles. So if this is 50, this is 30. This angle had better be 100. Why? Because it's still a triangle, guys. It's still a triangle. Triangles add up to 180 degrees no matter what. All right, last piece here. Now, this is not a mid-segment. This one is not a mid-segment. It just happens to be parallel. Okay, how do I know it's not a mid-segment, Mr. Heeren? I'm glad you asked. This is 4, this is 6. Mid-segments cut exactly in half. So here's kind of the way that works. It's in proportion. So this is 4 over 6. This is 7. This whole thing is A. So my proportion that I have is 4 over 6. I know that. To figure out this length right here, I'm going to take 7, and to represent that thing, that part, I'm going to take A minus 7. So A is the whole thing. I'm going to subtract 7. That'll give me that length. So 4A minus 28 equals 42. All right, hopefully I can skip that step by now. So add 28, 4x equals 70. So divide by 4, x will equal 1. 30 divided by 4 is 7. 2 left. 17 and a half. 17 and a half. So A is going to be, sorry, that's A. A is going to be 17 and a half. B, I'm going to do the same thing, except I'm going to say it's got to be 8 over B. All right, in proportion, in proportion, in proportion, in proportion. What you guys need to realize, and it's kind of hopefully going to kind of jump out at you at some point, when you draw something and they're parallel, you've created two similar triangles. All right, you've created this little triangle and this big triangle. When you draw that, you've created two similar triangles. How do I know that? Because the sides are in proportion. This angle is a part of both of them, so it's side angle side. So each piece is in proportion. So B equals 12 for that reason right there. That's all I got. Come talk to me with questions, and let's start studying for the quiz and the test and the final.